Here goes variation. So in this lesson, you're going to learn about three different kinds of variation. We have direct variation, inverse variation, and joint variation. So direct variation is y equals kx, where k is our constant of variation. Y is equal to k divided by x would be our inverse variation. And joint variation is when you have more than two variables and a constant. So that would be something like z is equal to k times x times y. And how we phrase it is, y varies directly with x. Y can vary inversely with x, and z varies jointly with x and y. So those are our three main types of variations that we're going to work with, but we can get into more complex types of variation as well when we add in more variables. So the first thing is, how can you tell if something is direct, inverse, or none? Well, what you want to do is get y by itself for these examples right here and see what it looks like. So if you get y by itself, you have to divide both sides by x here. And that's going to give you y is equal to 5 over x, which means that looks exactly like y is equal to k over x, so this is inverse variation. In the next example, again, get y by itself, so you multiply both sides by 5. And that's going to give you y is equal to 5x, which is exactly like y is equal to kx, so this is direct. Here's another example. None of our variations had a plus or minus sign, so this one's none. And this one right here looks exactly like y is equal to k over x. It just switches it, so this would be like x varies inversely with y. Same type of example, so this one is already set up to be inverse variation. Alright, so remember, get one of the variables by itself and you look at your constant and see what it looks like. So how do we write an equation? Well, remember, when it says y varies, that's like saying y is equal to. Now it says directly with z. Remember, directly is multiplication. So this would be your constant times z. So y is equal to k times z. In the next example, x varies. So x equals inversely with y. So that was when we took our constant and divided it by the other variable. So this is x is equal to k divided by y. Z varies jointly with m squared and n. So this would be an example of z equals our constant times m squared times n. And the last example is one of those more complex where we throw in multiple types. Y varies directly with x squared and inversely with z. So that would be y is equal to k times x squared divided by z, because it's directly with x squared and inversely with z. And that's just how you set up the equations. Now, some of those skills are going to be helpful in a few seconds when we start actually rewriting equations and finding values. When you're looking at a chart, this chart represents x and y. This does not represent k. So, does this chart represent direct, inverse, or none? What you want to do is you want to figure out how you would get k. So for direct, we know that that's y is equal to kx. So if we wanted to know k, what would we do? We would divide both sides by x, and we would get y over x is equal to k. So to look at a chart, all you have to do is y divided by x for every single one of those, and we'll see if we get the exact same constant of variation. For inverse, remember, inverse is y is equal to k over x. So if we were to solve for k, we'd multiply both sides by x, and we would get xy is equal to k. So to check if something is an inverse, all we have to do is multiply x times y, and if all of those are equal to k, then we will have inverse. And none is if the pattern doesn't work. So the first thing you want to do is you want to check division and then multiplication and see what you get. So remember, you do y divided by x. So 20 divided by 5 is 4. 16 divided by 4 is 4. 12 divided by 3 is 4. So this is a perfect example of direct variation. In this next example here, we have 20 divided by 1 is 20. 10 divided by 2 is 5. So it's not direct. So now you erase that and you try again with inverse. Remember, inverse, k is equal to x times y. So 1 times 20 is 20. 2 times 10 is 20. 4 times 5 is 20. Since all of them give us the exact same k value when we multiply, that is inverse. Next example. Start out with division again. 10 divided by 2 is 5. 15 divided by 4 is not 5. So you erase and try again. 2 times 10 is 20. 4 times 15 is not 20. So it doesn't work for division or multiplication, so this is an example of none. Okay, those are just some skills of how you recognize and how you write direct, inverse, and joint variation equations. So what we're really going to do is now apply it. So y varies inversely with x. We want to write an equation if x is equal to 2 and y is equal to 5. So we know two of the values. So since this is inverse, this is y is equal to k divided by x. Substitute what you know, 5 is equal to k divided by 2, and solve for k. So multiply both sides by 2 and you get k is equal to 10. Now that's just solving for k. It says write an equation. So this is an inverse variation equation. So the equation is y is equal to 10 over x. Okay, so that's part 1. Part 2 says find y if x is equal to a negative 5. So now what we're going to do is we're just going to use that equation, y is equal to 10 over x, and we're going to substitute in the negative 5 for x. So y is equal to 10 over negative 5, which means y is equal to a negative 2. And that's part 2 of this problem. So what you do is you first write the equation, and then you go back and do part 2 with the equation you found. Okay? So this next one, x and y vary directly. So you're going to start with your direct variation equation. Y is equal to k times x. We know x is equal to 20 and y is equal to 10. So we have 10 is equal to k times 20. So divide both sides by 20 to get k by itself, and you get k is equal to 10 over 20, which is 1/2. So your equation is y is equal to 1/2 x. So then we're going to use that equation. Y is equal to 1/2 x. And we're going to find x if y is equal to 40. So 40 is equal to 1/2 x. Multiply both sides by 2 to get x by itself. And you get 80 is equal to x. And that's it. So your two answers, part 1, y is equal to 1/2 x. The answer is not just k equals 1/2. It wants the equation. And part 2, x is equal to 80 when y is 40. Last example in the notes, joint variation. Z varies jointly with x and y. So z is equal to k times x and y. So now we're going to substitute in our information. We know that we have x is 3, y is 4, and z is 24. Start solving. So 24 is equal to 12k. So that means k is equal to 2. The equation z is equal to 2xy. Go back, and we're going to find z when we know that x is negative 2 and y is 3. So we have z is equal to 2xy. Substitute in your negative 2 and 3. So z is equal to 2 times the negative 2 times 3. So z is equal to a negative 12, and you are done. So that's it for this video on variation. This is Longo, and I'm out. See you, bye.